All right, here we're looking at our last section that we're going to go through in Chapter 6, and it's 6.6. And that learning target is down here at the very bottom. I can identify and write geometric sequences as functions. So really today we're just looking at geometric sequences. So the first thing we're going to really be looking at is we're going to come up with some vocabulary information for us to use as we go through this. Okay, so on your next clean sheet, so here was some compound interest information in my solving exponential equations. So on my next sheet of paper is where I'm going to label my page. So this is 6.6 geometric sequences. So now let's come up with some vocabulary and some definitions that we're going to use about what a geometric sequence is. So of course that goes in our very center. That's our vocab word. So that's our vocab. We're looking at a geometric sequence. So in our book, it tells us that a geometric sequence, the ratio between each pair of consecutive terms is the same. The ratio is called the common ratio. Each term is found by multiplying the previous term by the common ratio. So we need to come up with our own personal definition. So the definition that I like to think of for a geometric sequence is a pattern of numbers, right? And a sequence is always kind of a pattern. Where each new number is multiplied by a common number. Okay? Then in my notes right here, I'm going to give myself a little note because that common number, that's actually something important. That's another vocab. That common number is a common ratio. Okay? So that's kind of my definition. So it's a pattern of numbers where each number is multiplied by a common ratio. Okay. So then a characteristic. Okay, so these are kind of our important of like, what are we looking for? Okay, so we've got our common ratio. That's the thing I multiply by. Okay, that's kind of a big characteristic. The other thing is I've got just several terms. That's really what our sequence is different terms. So let's look at an example. I'm going to come up with one example, and I want you to try and come up with another example. So the example that I'm going to use right here is the one that we can see in the book. So if I start with 1, then my next number 5, 25, 125, ... continuing on and on. And I know that this is a geometric sequence because every time I go up, I multiply by the same thing. Okay, that's the important part, is I multiply by that same value. Okay, so now let's come up with some non-examples. Some non-examples, and we looked last semester at arithmetic sequences. That's where I add the same thing. So that would be a non-example. So if I'm going to add the same thing, so here I added 4, I would add 4 again, I would add 4 again. This would be an arithmetic sequence. So this is a non-example. Another non-example could be something that's not even a sequence at all. It's just some random numbers. Right? Again, I'm not multiplying by the same thing. Well, what if my numbers don't even have anything in common? Something like that. Those are not geometric sequences. Okay? So the biggest thing to note is that my ratio is always going to be the same. So this is going to go right in this page. If you want to trim around the edges, I'm going to do that a little bit before I glue this piece in. And then you are going to need one that looks like this, and you are told to cut one piece out. So go ahead and do that, and you're going to fold these flaps down, and we're going to fill out some information in each of them. I'm going to go ahead and glue this so it stays put while I write down the information that is really the equation for this geometric sequence that we're looking at. Okay, so here is our equation. this right here, the place that I told you to cut out, that's going to be your equals sign. So go ahead and do that. And then again, I do want you to use different colors here. So I have my a sub n, and it's really important that we know that this is it's a subscript, so it's below. That just tells us which one. Okay, so it equals a sub 1 times r. And here's kind of where we have to be real specific when we're taking these notes. Move my camera a little bit. So here we're going to have an exponent, which is n minus 1. Okay, so now let's fill out our things that we've got here. So our a sub n is the nth term. So you're going to be asked, so find the 17th term. That n tells us the 17, it's the number 17 in line, and the a sub n tells us what that value actually is. So our a sub 1 is the first term in the sequence. The r value, that's my common ratio. That's the thing that I'm multiplying by. And then my n minus 1, that's just the exponent that I use. So n, let's just go ahead and mark it in here. N is the same thing as the number in the row. So which term it is, that's how we can explain that. Okay, so here is our equation for a geometric sequence. Okay, so I'm going to write that, EQN of geometric sequence. Okay, so now that we have this, we can go ahead and use this information to plug in the things that we know. Sometimes you will not be given this stuff over on the right side and asked to find this a sub n. Sometimes you're going to be asked, okay, so what was the ratio? What is my a sub 1? So we're going to be really using this and plugging in the different pieces that we know and that we're given in order to find what we're really looking for. So one final thing I want you to notice with this equation is that we've been dealing with these exponential equations. This is the same sort of thing. We have seen this equation already. So y equals a b to the x. Same thing, right? So it's kind of where we start, what we're multiplying by, and then our exponent. So this is just a different form of an exponential equation that we've already been using. So now that we have all this information and then we've looked at this and we've seen some examples, I want you to go ahead and start working on that practice. And as always, contact me when you get stuck.